This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. And in yesterday's session, what we have seen how to create the AWS EMR cluster through command, through a particular command, how we will be able to create it. And from where we will be able to get this particular command. If you are not having this particular command, this is the format. Like you just need to provide the cluster name, then the details and all, where you are going to put the logs. Okay, these particular details you need to provide, but what will be the good practice? You just need to copy it from your previously created cluster. Let me show you AWS console, and let me log in onto this. And over here, these are the recently visited services, and let me go on to the EMR. And on EMR we will be able to see different clusters what we have created. You can pick any cluster, okay, and go inside the action, and over here view command for cloning cluster. And if you click on view command on cloning cluster, then you will be able to see this particular command. Just copy it and paste in a notepad, and then you will be getting the details how to clone this particular cluster. If you want with the different release, you can change the different release as well. If you want to change the location where you are going to put the logs for this particular cluster, you can change. If you want to have certain more instances, then you can add over here instance group, instance count, that is the master, and volume per instance 2, and instance count 2 you can increase it to 4. Then 4 core will be there. The instance type is also there, like 2x large, you can change that particular type as well. So it will depends upon you, like how you are going to move. You can move with this particular command as well, or you can move with the GUI as well. And what you just need to do, you just need to click onto the clone cluster. It will take these particular configuration and clone this particular cluster, and over the AWS cloud shell you will be able to run this particular command, AWS console, and over here only you will be able to run. So cloud shell. So onto the cloud shell, you just need to copy that particular command, and then you will be able to proceed for the execution. That is perfectly fine. Now moving further, what we have seen, like we have seen the different nodes inside the EMR cluster creation. We were able to see three types of node: primary node, core node, and task node. Primary, that is for master. Core node, over there slave machines are working, and these are having the capability to host the data as well, and utilized for the processing perspective. Task node, these are having the computational capacity, but they can't host the data. So we have seen three types of resources, instances basically. Instance, and with respect to the instance, we have seen on demand instance, type of instance, type of instance. So on demand instance, and then spot instance, and reserved instance. So on demand, like whenever you want a particular instance, then you can create it and you can choose the on demand type. Spot instance, which are given by AWS onto the heavy discount, almost 90% of the discount is there. But as and when required, these instances are taken back by the AWS. So whatever the query that is running over there, or whatever the data that is available over there, that will be lost at that moment. So what you can do, task node, what we are able to see, that is not able to host the data. So for task node, what we can have spot instances. So that will provide certain computational capacity for your cluster, and you will be able to do the execution with low latency, as you will be having huge computational power. Yesterday, in yesterday's session, what we were able to see, once we were running with two machines, so we were not able to do the execution, and the query was stuck, and it was taken almost 17 minutes for the execution of that particular task. Just have a look over here. We will be able to see the details. EMR cluster, I think this was the cluster. Okay, and inside the steps details, steps, and okay, this was not the cluster, this was the cluster terminated. Oh, no, the previous one only. This was the cluster, and inside this we were having certain steps, and this particular step, just have a look over here, it has taken 17 minutes, and because at this moment what we were having least computational power, and the query was unoptimized, so we have done the optimization, and we have increased the computational capacity, then the same query was able to get executed within 30 seconds. So this was the stuff, like once we are having uh, once we want to have certain task nodes, so task node we can provide the instance type to spot instance, and we will be able to get the more computational power, and if it is lost, if it is terminated, or if it's taken back by the AWS, then nothing will be lost. Data will not be lost, because this task node are not able to host the data, so no data will be there. Yes, there will be certain issue on to with respect to the task which are being executed by this task node, task node of spot instance type, but like that will be the duty of your driver inside the Spark. It will be, or application master, it will keep monitoring of the tasks which are being executed inside the slave machines. If one machine is down or one instance is down, then it is going to align those particular resources or those particular tasks to the another machine, or other another executor. So that is the normal functionality. But what I want to say over here, task node can be of spot instance type in order to get the functionality, in order to get the computational power. Then we have gone through with transit versus long running cluster. And transit cluster, once the application is completed, then the cluster will be terminated. But with respect to long running cluster, it will be running for a longer duration, say 1 year, 2 year, or 3 year. And once the application is completed, the cluster will not be terminated. That is the long running cluster. Then we have seen the instance, the storage level, or in another words, you can say the disk which is given inside the machines or instances in order to store your data. So that particular storage is of three types. Instance store is tightly coupled with a particular instance. If you are going to terminate an instance, let me show you. So we are going to create an instance, say EC2. EC2 instance we are going to create, and I'm showing you the process how to create it. You just need to go into the instance running, how to create an EC2 instance, and launch instance. So once you are clicking onto the launch instance, so how many instance you want to launch? Say I just want to have one instance, and you can give a name, say Booster Analytics. Booster Analytics INS or Machina. Booster Analytics Machina. Probably it will throw error. Booster Analytics machine. Then the operating system. Which operating system you want to have? So like I want to have say Amazon Linux. If you want to have the Mac OS, you just need to click the Mac OS. If you want to have Ubuntu, Windows, Red Hat, or different Linux, so you just need to click or choose that particular instance operating system type, and then you will be able to have it. Say I have clicked onto the Amazon Linux, that is 2023 AMI, and the instance type. Just have a look over here onto this, that is the free tier eligible. If I'm going to create this, so it will be available at free of cost. It will be available at free of cost, and this will be like 64-bit operating system, and that will be the AMI ID, verified provider. These are the basic things. Now the instance type, what we have seen different instance type, and over here you are able to see the pricing. Say this is T2 micro, and with respect to T2 micro, what you will get one vCPU and 1 GB of memory, and then what will be the price for this? So if you are going to purchase say Windows, it will be of this particular price, 0.0162 dollar per hour. If you are going to purchase say Linux, so it will be 0.16 0.0116 USD per hour, and for T2 micro that is free of cost. Say, and what we are having, say if you are having certain key pair, so you can select a particular key pair. So we have created this data engineering key pair. We can choose that particular data engineering key pair. Network settings, each and everything is fine. We will proceed with the default settings, and configure storage. So if you want to have certain more storage onto this particular machine, you can add it over here. Add new volume, you can add new volume as well. And let me click onto the launch instance. Okay, so success, the instance has been launched. Let me click onto this particular ID. Okay, it will be taking some time. Like this is the Booster Analytics machine, and instance it is pending. Soon it will be ready. It will be in running state, and then I will be able to access this particular machine. So still pending. Oh, just have a look. It is in running state. It is in running state. So what I just need to do, and just have a look onto this. This instance is in running state. The instance type is T2 micro, and then status check, initializing, alarm, no alarm is there, which in which zone it has been created. So that is US East 1B, and public IP, and public DNS, public IP, elastic IP. We will be covering what is elastic IP as well. Monitoring disabled, and then launch wizard for data engineering key is utilized, and this is the launch time, and platform is Linux. So what I just want to access this, and all of the things that we have seen, these are we will be able to you can say see those particular things. Let me click onto the connect. So I just want to connect with that particular machine, and what I just need to do, I just need to click onto the connect, and I will be able to access that particular machine. Just have a look. So it is establishing connection with that particular machine, and I will be having that particular machine. So Amazon Linux, this is the machine, and ls is nothing is there. I can say create directory over here, make directory say booster analytics. Okay, and say ls. So as it is running onto the linux operating system, so we will be able to see, we will be able to create uh, directories, files over here. Then if you want to have the installation of certain softwares onto the linux front, you will be able to install those particular software as well. If you want to load certain data from s3, then you will be able to load. Okay, and you will be able to do the processing. This is one machine, and you will be able to process your data over here. That is linux machine, and you are having one machine that is created from the free tier of aws, and we just need to bear the minimum charges for this. Okay, so in this particular way, we will be able to create the EC2 machine. Let me go over here and create these particular names will be changed. No need to worry. So what we were able to see, how to create EC2 instance. How to create the EC2 instance. EC2 instance. Okay, and how to access the EC2 instance as well. These particular things we have seen with practical, and like process is very simple. You just need to go into the EC2 dashboard, and how to go, how to create it. Go on EC2 dashboard, click on instances, click on create instance, provide the instance name, choose OS, and instance type, instance type, provide the key if you are having, click on create EC2 instance will be launched. Okay, okay, so this is the way in order to create an EC2 instances, and these are certain steps, steps to create an EC2 instance, steps. Now, what I want to say over here inside the EMR and EC2, okay, in both of these two services, these are two services basically. These are in these services, in above services, we need to create the cluster, choose instance type, and then perform the operation. That is the normal flow. So once we were moving with EMR, what we have done at that moment, we have created the EMR cluster, and then we tried to connect it with Putty. Then we have done the execution of our jobs via Putty. We have done the execution of our jobs through the GUI option, and we have submitted the application which are available onto S3. Data is available on S3, and we have read the data from S3, and write the we have written the output onto the S3. Yeah. So these particular things we have done, but for those particular things we need to have EMR cluster first. So we just need to create the cluster, and then we will be able to run the operations or application. However, we are having recently, like EMR has launched the AWS has launched EMR serverless option as well. That I have not explored yet. That is the new service from the AWS side, EMR service serverless. Let me show you. So first, let me try to terminate this, because I don't want to pay more. So instance, this is in running condition. What I just need to do, I just need to click on this and terminate instance. Terminate. So it will be shutting down. It will be terminated soon. So disable termination option. That is disabled. So it will be terminated. So the instance has been terminated. We are not able to see anything over here, and same thing we will be able to see over here. Although like one instance we are able to see, but that will be gone. It has been terminated. So what I want to say, EMR serverless, I just want to show you EMR. And over here, if you are able to see EMR serverless, where is that? EMR serverless. So EMR serverless is being launched, is the new service that is launched by the AWS. So over here, there is no need to create the cluster. You just need to do certain configuration as in when required. The server or all of these particular machines will be given by AWS, and there is no need to create the cluster. Whatever we have created, so that particular stuff is not required over here inside the serverless. And these are the price related information. If we are talking about the serverless, we just need to provide the initial and the required core and memory related stuff, so that those particular things will be there in reserve for you, and whenever you require, those particular things will be launched instantly. Yeah. And you will be able to do the execution, or in another words, once we were having an application, so before before you can say proceeding for the execution of an application, we just need to create the EMR cluster. But EMR serverless is saying just come with an application and do the execution, then cluster creation and all the rest of the things will be taken care by AWS. So that is the serverless service from the AWS side. EMR serverless. In the same way, what we are having Athena as well. So what I want to say, EMR and EC2, for these particular services, we have created the EMR and EC2 cluster, EC2 machine, basically instance, single instance was there. If you want to have multiple instance, we can have that way as well. But we have created the single instance. But with respect to the EMR, we were having multiple machines at that moment. Now another service, that is Athena. Athena. So Athena is the serverless service from the AWS side. So Athena, this is serverless service service from AWS side. There is no need to create cluster in order to have this particular service. So there is no need to have cluster creation for Athena. Now, what we need to do, just try to think in this particular way. We are having data that is available in S3. Data is available in S3. Okay, S3 is the data lake basically. Data is available in S3, and what we are going to do, we are going to create a schema. On to top of this schema is nothing but metadata. So we are going to create a schema, and that is nothing but metadata, metadata or metadata. So over here, what we are doing, data will be kept inside the S3, and we are going to build a schema onto top of that particular data, whatever we are having, and then we will be able to query on this particular data, and we will be able to analyze it in the tabular view. So we will be able to do the execution with SQL queries. Say something is there inside the S3, and we know it very well. The data is placed in terms of files inside the S3. S3 is nothing but the object store. So data is placed in terms of files, and say we are have objects basically, and what we can do, we can create certain tables onto top of that particular data inside the Athena, and that is possible by creating the schema on top of that, and then we will be able to access or query that particular data. but but the main thing is that data is placed inside S3, and we are able to query, we are able to do the analysis based upon this particular service. But how the AWS is charging? How the AWS is going to charge you? Because over here inside the EC2 service, based upon the node or instance that we have selected, we are uh, the AWS is going to charge inside the EMR as well, based upon the the nodes. It might be primary node or support instance or core instance or task node, whatever the instance that we are going to take, and the type of instance. Based upon the type of instance, AWS is going to charge us. So that is the case, like AWS is charging. But what will be the case in terms of Athena? Because over here we are not going to create the cluster, we are not going to host certain machines or nodes. Okay, now how that particular charging will be done? We are performing our operations, and nothing is free onto AWS. It is not providing these particular things at free of cost. So over here, as we are not creating the nodes, so how the charging will be done? It will be, or AWS is going to charge us based upon scanned data. Okay, and if you are going to scan say 5 TB of the data, then the charge is 1 TB, and charge is say $5. Let me check the correct price. Athena and okay, so just have a look over here. Okay, $5 per TB. Yeah, SQL queries per TB scan. That is the charge. AWS is going to charge based upon this particular standard. If we are having 1 TB data and if we are scanning the entire data in a SQL query, then it is going to charge $5. And Apache Spark calculation, that is if we are going to, these are certain charging methodology. On provision capacity, these are with respect to say Spark. So how this is going to charge? SQL queries based upon five SQL queries per TB, $5. Then SQL queries on provision capacity, that is uh, $0.3 DBUR. DBUR. So, and once we are talking about the Spark calculation, that is 0.35 dBu per hour. DBU, that is nothing but data processing unit. DBU, CPU. Okay. So this is nothing but certain, you can say, measures which is being done inside the AWS Glue for uh, for processing the data and all. We will see once we will be going through with the Glue. So we will see this DPU related stuff at that moment. Over there inside the Glue, we will be able to run the Spark jobs as well. Okay, we will see these particular things over there. But now what we are going to say, we are bothered about this SQL queries and all. And if we are having certain data and based upon the scan data only, it is going to charge us. It means nothing is free inside the AWS. If we are if we are going to perform certain operations, then based upon the type of service, we need to pay certain charges to AWS. Over here it is charging based upon the scanned data. Okay, so what is the meaning of scan data over here? Now, say I'm having a particular table, and table is having the size of say 500 MB, or say 5 GB. The size of the table is 5 GB, and if I'm performing the query, select star from say table name is say booster analytics tab. So this is the table name, and if I'm performing the query, select star from booster analytics tab. So it is going to scan the entire data. Select star, that means it is going to scan the entire data. So, and what will happen? The charge for 1 TB is $5. So 5 GB divide by uh, divide by 1 TB, yeah, 1 TB cross that is in this particular way. 1 TB, 5 5 5 divided by 1 TB, okay, and multiply by what? 5 GB. Yeah. Okay, so this much charge I just need to pay for this particular 5 GB of the data. Okay, that is a simple mathematics. If like 1 TB price is 5, 1 TB price is $5, then we just need to, you can say, convert it into the GB MB. Yeah. So say 1000, that is nothing but 1024 GB. Okay, 1024 GB. This is the price for say 1 GB, and if you want to get the price for 5 GB, cross 5 GB. Yeah. So in this particular way, I will be able to get the price for this particular query. Yeah. Based upon the query, I just need to pay to AWS. Now that is fine. Like what is Athena, that is fine. How it is working, that is also fine. How AWS is charging, that is also fine. But why and when we need to use Athena? When we need to use Athena? So definitely, once if we are having frequent queries, if we are having very frequent queries, then this particular solution is not made for the frequent queries. Like if I'm going to perform the queries again and again, and we know it very well, so AWS is going to charge based upon the queries or scan data, then this particular solution will not work. So what I can say, this is required when we are having infrequent queries. This is good once we are having infrequent queries. It's very simple, and we are able to see, say if we need to pay based upon the scanned data, then then if we are having very frequent queries, then this particular solution will not work. We don't suggest this particular solution. Being a data architect for your organization, you just need to avoid this particular uh, service uses if you are having frequent queries. Uh, if we are having frequent queries, then we can create the EC2 machines, or we can create an EMR cluster at that moment, and we can proceed for the execution. But for infrequent queries, we can create the Athena cluster. Now that is also fine. But it might be possible certain queries are failed, okay, and we are not able to get the data. What will happen in that particular case? So for those particular things, AWS has created certain rules. So what are those rules for charging? So number one, AWS is uh, AWS is not charging for DDL queries. Okay, DDL queries, that is creation of table.
G is
Creation.
missing in charging, sir. G is missing. Please mention that.
Come again.
G is missing. G alphabet is missing in charging. Please. G.
Sorry, my
Okay.
mistake, friends.
Yes.
Okay, charging. Creation or deletion of the table. This is data definition language basically. Creation or deletion of tables. If like we are having certain data inside the S3, then what we need to do, and if we want to do the scanning onto top of that particular data, definitely we need to create tables onto top of that. So creation or deletion of the tables is not a point for charging. It is not going to charge for that charging. Okay, so for that it is not going to charge. Now number two, for the failed queries, failed queries, there will not be any charge. Any charge. Okay, there will not be any charge. The AWS is not going to charge a single penny if the query is failed, because that is the issue from the AWS side, if the query is failing. Or it might be possible, like you have mentioned certain things, those are not, you can say, correct with respect to syntax and all, and because of that the query is failed. So what we can say, at that moment the AWS is not going to charge. Then the third point, what we are having, the query is running, and you have cancelled cancelled the query. At that moment, AWS is going to charge you based upon the data what you have scanned. Okay, so based upon the data, whatever you have scanned, then AWS is going to charge. If you are going to cancel the query in between, like query is running perfectly and you will be, and at that moment you realize that, oh, this particular query is going to scan say 5 TB of data, and at that moment in between of the query you realize, and what you think for a solution, you are like moving with canceling that particular query. You press the cancel button. At that moment, it is not like AWS is not charging you. AWS is going to charge you, but based upon the scan data at that moment, whatever you have scanned, so it is going to charge you. So these are certain basics with respect to the with respect to the Athena. Now let's proceed with certain practical related stuff from the Athena side. Okay, so what we are having, we can have a particular table. So let me try to get certain details. This was the stuff what we have executed in our previous session. So we are having this particular data, that is small flights df, and I just want to check say dot d type. D type. I just want to print the data type of, just for information perspective, I just want to print the data type of the small flights data. I just want to get the data type of each and every column from this particular data frame. Small flights. Okay, so we are able to get the details, and these particular things we are going to utilize in order to create the schema onto top of this particular data. Okay, so data type of small flight df. Okay, and how we have got this d type and print this one now. Okay, so these are the data types. These particular things will be utilized once we are going to create a particular table on to top of the data which what is stored inside the S3. Now, what I'm going to do, launch query editor, and with respect to the launch query editor, data source, AWS data source, I'm going to uh, create a table. So I'm going to create the table from the S3 data. Okay. And I'm going to create say data, say small flights data, small flights data. That is the table what I'm going to create. And description, I'm not going to give the description. Then I'm going to create a database, say booster analytics. Booster analytics, that is the database what I'm going to create. And data, from where I'm going to select the data. So inside this particular booster analytics 2 flies data, and I'm having this particular Athena test. So I'm going to select this Athena test and I'm going to choose this. I'm going to create a particular Apache table type, Apache Hive type. File format, you can choose the file format. Okay, so uh, data format, table type, table type is text, the CSV type, and okay, that is fine. Now now what I just want to give, I just want to give the column names from this particular data. So year is the column name. The column name is year. The data type is string. So string, add column. Then what I'm having, month is of string type. Okay, string, perfectly fine, add column. Then day is of string type. Day is of string type. Okay, so depth time, departure time, add column. Departure time, that is of, say, that is also string type. String type. And what we are having, depth delay, depth delay, and that is also string type. Then arrival time is of string type. String type, add column, and then arrival delay, that is also string type. Then carrier, that is also string type. Each and everything is string. String type. Tail num is of string type. String type. Flight is also of string type. String type. Origin string type. Destination is of string type. Okay, so air time is also string type. Okay, so over here, like you will be able to change this particular data type as well. There is no, you can say, hard and fast rule that you need to keep this particular data type. Distance, the distance, what I can mention, say long or small integer, integer. Tiny integer, small integer, and integer. But we just need to check this particular data before providing the data type related information of flight data. So small flights, so these distance or minute we can provide in integer format. Distance or minute or minute. So we can have this in integer type and minute. Integer type. We can change the integer. Okay, that is perfectly fine. Okay, CSV file. And over here the query is being generated. Create a table if not exist. Booster analytics, that is the database name. Small flights data, and these are the columns that we have created. Okay, and row format shared a, so serialization deserialization because we have selected the hive with properties delimited because the CSV file is there, stored as input format, then hive key location is of this one, and table properties classification CSV, and each and everything is looking fine. Create table. Okay, so okay, table has been created. Table has been created. Now this particular query that we have, although like we can write this particular query as well, but what we have done, we have utilized the graphical user interface, and with graphical user interface we have created this particular table. We have created command for table creation in Athena. Okay, so we are able to create the table. So in the same way, like what we have done in EMR, we were able to create it, the EMR cluster with GUI options. So this is the simple table creation command. Create table. The table name is given. Over here, the external table has been created, but because the data is existing over here onto this particular location. Okay, external table, and the classification table properties because this is of CSV type, and row format serialization deserialization, and stored as this is the input format and this is the output format. However, like we can remove these particular things, this one and this one, then also we will be able to create this particular table. Okay, but let me try to run certain queries onto this, say, uh, so what I can mention, so table has been created. Let me delete this. Say select uh, tail num from booster analytics dot small flights. Okay, we are going to select and limit and 20. I just want to have 20 uh, tail numbers. Tail number is the you can say column, or column what we have created in this particular data, okay, table basically. So tail num, and we are going to select top 20 tail numbers. So it is executing, and that's what we are able to get. Now the data is stored onto the S3 location. We will be able to perform operation now, like the SQL queries grouped by or short, okay, joins and all, each and everything, whatever we want, the tabular operations we can perform over here onto this particular data. But what we just need to keep in our mind, we just need to keep the thing like it is going to charge based upon the scanned data. Over here what we have seen, we are able to see that we have loaded this particular table. Further, like we can do certain optimization in order to minimize the amount of scanning. In the next session we will be going through with those particular things, like how to optimize, how to do the optimization onto the Athena table so that the scanning will be less. Our main motto over here, because it is going to charge based upon the scanned data. So we just want the scanning must be less, and it must be like it must be optimized with certain properties like partitioning and all. If we can do the partitioning based upon this particular table, so we will be able to get the scanning low amount of scanning, or column pruning, or you can say partitioning. There are different things what we can do uh, that can be utilized in order to minimize the amount of scanning. And just have a look over here, what I want to say. So it is going to show the scanned data. Just have a look at the scanned data. So for this, it has scanned 599.70 kb of the data. But in our table, this is all 600 kb data. And if 600 out of 600 kb data, it is almost scanned the entire table. Okay, so it means this particular data, that the data placed in this particular table is not in optimized format. We can minimize this particular amount of scanning. We are scanning single column only. We are getting single column only, but this scanning it is going to scan the entire data, entire table. So we just need to work in such a way that this particular scanning is reduced, and we need to pay less charges for the data scanned. Hope you are able to understand the concept, or the things whatever I have explained. Vandana, Shivam, Naresh, and Swati. Are you able to get Athena, the another service from the AWS side? So what we have done, let me repeat it once again. So we have started a new service, that is creation of EC2 and Athena. Two services we have covered in our today's session. First one, like how you will be able to create the EC2. So these are certain steps. You just need to go onto the EC2 dashboard. You will be able to see instance over there. Then click on instance, create instance, and you will be able to proceed with these particular steps, and you will be able to have the EC2 machines, EC2 cluster. EC2 machines basically, not cluster. We have created the single instance only. That is not a cluster. So we can do that is a Linux machine, and you can utilize that particular Linux machine in order to perform certain operations. Now another service what we have done, we have covered, that is Athena. So Athena is the serverless service from the AWS side, and there is no need to create cluster in order to utilize this particular service. And it is working in such a way like data will be placed onto the S3, and we are going to create a schema onto top of that, and then with the help of that we will be able to access. So what we have created over here, we have created the schema only. The data is available in our machine, and we have just copied the schema of that particular data. Or you will be, if you are having the information, so for the easiness perspective we have copied the column names and all from that particular uh, CSV file, and we have defined the schema. And it is not like say from the command we are getting say string data type, but the inside the data that on S3, different data type is available, data is in available in different format. So based upon the data that you are having, you can provide the data type with the drag and down options. So you will be able to create the schema, and then you will be able to access over here. Once we are accessing a particular table, then we are able to see the entire table, entire data is scanned. So we just want to do certain optimization onto top of this. In the next session we will be going to create certain optimization related stuff onto this particular table, and then we will see the scanned number, like is it minimized or not. We will be working on that. Another concept what we will be going to cover. So over here, if you are clicking onto this, so create a table from the data source. You are able to see say S3 and the AWS glue crawler. So we will be going through with this particular aspect as well, how to create the Athena tables with AWS glue crawler. Over here we just need to like provide the data and the column names and all, but over here it will be going to provide an option for inferring the schema. So we will be able to infer the schema with glue crawler. So certain easiness is there, and it is going to provide, it is going to check the data which is stored inside the S3, and based upon its understanding it is going to provide the schema. Then further we will be going to change if like the data type that is given by this crawler, if you are not okay with that particular data type, you can change that particular data type, and you can have your own customized data type. So that particular thing we will be going to cover in our next session. So that's it for this particular day. Hope you are able to get the things in detail. Vandana, Shivam, Naresh, and Swati. Anything that you are not able to understand, anything that you are not able to consume. Guys,
Yeah, sir.
mm-hmm.
Uh, Here we take that table as an example to scan. We have to scan complete table or one column only.
Actually, we have gone through with single column only. Over here, we have scanned the single column. We mentioned single column only, but at this moment as well, it is going to scan the entire data.
Yes, 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 sir. That's my
Okay.
question is also, sir. We have taken that to scan only one column, but it scan complete table. Why it scan complete table?
The thing is that basically over here in this particular data, uh, in this particular data, okay, so these particular columns are available. Okay, in this
Okay.
particular table, all of the, almost like 11 columns are there. 16 columns are there. These particular 16 columns are there, and we have selected this particular column only. So over here onto the data, just have a look onto the S3 location. Okay, onto the S3 where the data is placed, that is placed inside a single file only. We are reading the entire file in order to get this particular record. So how we will be going to minimize this particular scanning? We will be going to make certain partition onto this particular data. Okay, at that moment if we are going to scan the single column, so it is not going to scan the entire, you can say, file, entire number of records. Almost 10,000 records are there in this particular file. So if we are going to say mention 20, so from one partition only it is going to pick 20, and it is going to scan only that much of data which is available in that particular partition, right?
Right, right, right.
Okay,
Okay, sir. Okay.
so this is the single file. Let me show you onto the S3. Okay, S3. Let me open S3. Hmm. 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 So this is the size of this particular file. Single file is available. Based upon this particular file, the table is created, and it is going to scan the entire, you can say, uh, table which is created onto top of this particular data. Let me try to write another query. Select star from this particular table data. Run. Okay, so the query has been executed, and at this moment as well, the scans is 599.878. Almost the same scanning. Are you able to get?
Yes, yes. Got it.
Okay, so we just need to optimize this particular stuff. And okay, this particular. Okay, we are going to see certain optimization over here. Like it is taking these particular, you can say, first row as well. We just need to remove this particular row. We will perform a lot of optimization, but what I want to say, even like we are scanning the single column, it is going to scan the entire data. And if we are selecting the all records from this particular table, then also it is scanning this much of data. So we just need to think in that particular way how we will be able to minimize this amount of scanning. How we will be able to minimize this particular scanning. So we will proceed, we will do certain optimization onto top of this particular table in order to have the optimization, and then we will see, right?
Right, sir. Right.
Okay.
Okay, sir. Okay. Thank you.
Okay, Swati, Shivam, and Vandana. Any confusion? Anything that you want to ask?
It's fine, sir.
Perfect. Now, Shivam and Swati and Vandana, is it fine for you? Okay, no worries. Let me conclude the session for the day. And in the next session we will see how to do the optimization onto top of Athena tables and create the Athena tables based upon the glue crawler. So that is the thing we will see in our next session, and next service will be started at that moment, that is nothing but AWS glue. Take care friends, have a
Okay,
good
sir.
day.
Thanks. Thanks a lot.